Welcome to this training course on load control. We are going to discuss the rationale behind load control and talk about how it is the primary application of the Infusion system. And so having a working knowledge is fundamental for your success with the Infusion system. Now, the objectives of this lesson are going to be, we're going to talk about what an electrical load is. We'll talk about dimmers. We'll also discuss the methods and terminology involving those dimmers. And then we'll help you make sure that you're matching the correct load with the options that are available. We'll discuss fan speed control and switching control. And then we'll also discuss load control form factor options. And so that'll cover both centralized and a distributed load control systems. Now, first off, let's talk about the definition of a load. An electrical load is any electrical device that draws current when electric power is applied. For example, one light fixture or groups of light fixtures that are switched together, a ceiling fan, an exhaust fan, a pump motor. In a lighting control system, a lighting load is often also called a lighting zone. So what does it mean to control a load? To control electrical load is to regulate the power that is delivered to it. So you either have your simple on-off, which would be your non-dimming lights, your fluorescents, HIDs, LED type of lights, and then your exhaust fans and pump motors. Then you also have your variable power delivery, which are your dimmable lights and your multiple speed ceiling fans. So let's go into the fundamentals of dimming. Choosing the correct dimmer. There is more than one way to dim. You have phase control dimming, which covers both forward phase and reverse phase. You have low voltage control options, which is analog, is your 0 to 10, and your pulse width modulation or PWM type of loads. And then you also have digital, which is your DMX and your DALI type of loads. So let's jump into phase control dimming. So with forward phase and reverse phase, you'll notice first thing from this diagram of this sine wave is that you can see that there's a delay on the forward phase at the front half that cuts off the top half of that half cycle. As you can see, we're shutting off the power to the light each half cycle. On the reverse phase, it's the opposite. You can see that there's actually the chop at the back half of that half cycle where the delay is put into place. The longer the power is off, the more dim the light. Now, keep in mind, it is not automatically a linear, which would have been ideal. So in forward phase dimming, we have either a triac or SCR technology that we utilize. There is a minimum load requirement with the forward phase dimming. Some of the terms you'll hear involving that are your standard dimmers, your triac dimmers, leading edge dimmers, household dimmers, and magnetic dimmers. Now with reverse phase, this utilizes the IGBT or FET technology, and nice part about that is it doesn't have a minimum load requirement. It does also have a lower power rating, which generally isn't a big problem because the fixtures are generally consuming less power. But the one downside or major downside of this is that it is more expensive to build. Terms you'll hear with this is an electronic dimmer, ELV dimmer, and trailing edge dimmers. Now let's talk about compatibility. At a quick glance from this list, you can see that there's not a lot of definitive answers. You have to be able to get into whatever the fixture or bulb that is getting spec'd out and make sure that you're verifying whether it's a forward phase or reverse phase or which one is better suited for that specific fixture. As you can see, the second line down, magnetic low voltage loads are really the only type of load that we know for sure is 100% forward phase. Everything else, you have different manufacturers who might make some things forward phase and they might make other things reverse phase. So the gist of this list is that you need to do your due diligence and check with the manufacturers and find out and understand what the fixture does, whether it's forward phase or reverse phase. One other thing we want to talk about is variable fan speed control. First main point, do not use a dimmer on this. It is not designed for that, and the reason being is that the dimmer does not vary the capacitance in parallel to the fan motor, which is required. And so you can cause problems to the motor and to the dimmer of that device. So let's go into load control form factor options. So first off, your configuration, you have either new construction or retro applications where you're applying this. The centralized is your enclosure-based system. A distributed would be your switch replacement system. That would entail your wire link, radio link, and RFLC devices. And then a hybrid would be a combination of both the centralized and the distributed system, all in the same system. So first off, the centralized system. This is where you have your breaker feed straight from the breaker to the panel itself, landing on the enclosure. Then you have the light load run as a home run down to the enclosure itself. And then you have low voltage keypads out where the switches would be with a daisy chained home run wiring scenario of the Vantage station bus. And then you have the Infusion controller as the processor that does all of the commands. Now in a distributed system, this is your standard switch replacement. So once again, your breaker goes to the switching location, the light load comes down to the switching location, and then we would have a daisy chain to all the different stations of the station bus. Or in a retrofit application where you cannot get the wire into that place, you would use the RF equipment that we have and use the radio link scene point dimmer and use the RF enabler, which would communicate with those stations for communication bus, or the RFLC enabler as well as the RFLC stations, giving you the ability to control the loads without having to run any wires. Or a hybrid system, for example, if I had a home that was under construction, but it was a remodel and additions, so I was able to get wiring in to a lot of the locations. I was able to get the panel-based system, which gives me the best load control options and things like that. Then I would use a panel-based, but then maybe I've got some locations that the loads are already run, but I can drop a wire from the ceiling or the attic area down into those locations, and I would get a wire link scene point dimmer. And then maybe some of those areas that it's just too difficult or not worth the time to get a wire into, I would add a enabler and be able to add the radio link and or the RFLC loads to the system. And that gives me a hybrid of all the different systems. Something to point out from this graphic, notice that whether it's a keypad, low voltage keypad, or a scene point dimmer or radio link dimmer, for example, with this style that I'm presenting here with the Easy Touch 2, they all look alike. And so, you know, the homeowner would never really even know that whether it's a low voltage keypad or a high voltage scene point dimmer at that location. So it's aesthetically pleasing. It matches all the way across the board. So the next part we're going to go into is the enclosure modules for that centralized load system. The first one is the new standard dimmer module. It just came out in 2012. This is the SDM12-EM. It is our forward phase dimmer. It has 4 20 amp fuse line feeds into it. And this one model covers the 120 through the 277, so both residential and commercial applications with this one piece. Now, it has 12 loads built into it now, so that's an increase from the old one, which used to be 8. And keep in mind that this has a 5-watt minimum, which is a decrease on the minimum, and that's nice, so that if you have any, maybe I'm doing a single art light or any of those type of low LED type of fixtures that draw a very minimal amount of current, I'm not going to have the type of issues that I might have had with the older standard dimmer module. Something I'd like to point out right now, with the 420 amp fuse line feed ends, if I don't need that many breakers, I am totally open to be able to run jumpers from line feed A down to line feed B between the line and the neutral and use only one breaker per side or one breaker for the entire module if I really don't have that much call for wattage. Also keep in mind here that you do have 1,000 VA maximum if you're using magnetic loads, and that is per line load. All right? And an additional piece that we put in with this new SDM12 is that it has a relay per load, which prevents the snubber circuit current leak. This is in addition to the minimum of 5 watts. So what this gives you is that if you've even got a really low load that's on, let's say, load 1, and you have load 2 that is on, because of that snubber circuit, now you won't have any current leak, which would cause like a low LED to still stay on, because the system wouldn't see that. So the relay per load is a nice piece to be added into that. We also added a current and voltage sensing per breaker or per line feed, and you can do different things with that. For example, you could have an email sent to you or sent to the homeowner if either of those pieces got over or under what the sensing was set up for. Now, this new STM12 does use a new black AC power terminal board. And so when you go through the ordering wizard, you'll notice that you are checking a different box on that. If you're doing a retro application, you need to make sure that you're ordering the right one. If you want 8 loads, you order the retro. If you want all 12 loads and you're going to use that additionally, then you use the just the standard terminal kit. So the eDim mod, this is our reverse phase dimmer module. And this one has two 20 amp non-fused line feeds in. Doesn't need a fuse, it's internally shut off protected. If you have a problem, you click the breaker off, bring it back on, and everything's reset. This is only 120 VAC, and it has 8 loads with a 6 amp maximum per load. You have a D-rated 16 amp or 1920 per line feed in. And this does use the standard green terminal boards still. So the next module I want to talk about is the MDRA 101 and 201. This is our relay module. It has 4 20 amp live feeds in. The 101 is a 120 volt model. The 201 is the 210 to 277 volt model. This does have 8 loads with 16 amps each, up to 16 amps each load. This does utilize the green terminal board as well. Something to always keep in mind, any Infusion native dimmer can be used as a relay, and so in the software you would set that up so that it would function as a relay. The next model I want to talk about is the MDR8 W301. This is our commercial relay module. This has a 1-to-1, so you have 8 20 amp line feeds. It does cover the 120 to the 277 and with 8 loads. So as I said, 1-to-1, so I can have a full 20 amp breaker on each load that's out there. So this does use the commercial terminal boards. So very similar to the standard green ones. The only difference is that there's not a lot of space for neutrals, and so you would wire nut all your neutrals together except for one pigtail that comes out and connects up to one of the green terminal boards. So the last module that I want to talk about is the fan mod. This is a 4-speed fan module. It has 2 20 amp line feeds in, and this is for 120 volt systems. This has 8 loads, up to 2 amps each load, and this is designed for ceiling fan only. And you are to utilize only 1 fan per load, and this is because of the capacitance being varied. Once again, the same sort of thing that why we don't use the dimmer modules to do it. If you put multiple fans in series, your capacitance is going to be adjusted incorrectly, and you can cause damage to the motor and to the module. This does utilize the green terminal board. Another thing to keep in mind is that we do have the fan cap. It is an alternate to this fan module. It uses 2 loads, and it would give you 3 speeds with this piece. And I would use, for example, the relay module, use load 1 and 2, and then I can get a combination between 1 for being a medium speed, 2 on would be a low speed, and 1 and 2 on would give me a high speed. So that's another piece that you can utilize. Really just depends on whether I've got extra loads on my relays as I'm designing up the system, or if I'm going to have only 3 or 4 fans on a project or in a certain panel, then maybe utilizing that space with a fan module may not be the best alternative. So let's look at the indicators that are on the module. The first indicator that we're going to look at is the incoming line voltage. Notice that there's 4 of those, 1 for each breaker feed that is in. Then the next one over is the fuse, and this is for the standard dimming module only that you see this fuse light up. Then you have an indicator for all of the loads. For example, in this picture, you've got the 12 loads on the standard dimmer module. And then you have the processor status, that vantage heartbeat that just blinks steady if everything is good. And then you also have a manual control, which if the system is thrown into override, this would be lit up. You have an overheat condition. You also have an overload condition light that would give you an indication if there was a problem going on with this piece. Also notice in the middle section there the dip switches for each individual load that's on the module. So let's talk about the centralized load enclosures. The enclosures come with the IMPE 4 or 2, which is your main enclosure, either a 4 module or a 2 module, and you can order these in a 36 volt or a 24 volt terminal boards for the controller. We also have the secondary enclosure, which is the ISPE -4 or 2, depending on if it's a 4 module or a 2 module. And this secondary enclosure is basically designed to extend the amount of loads that the master controller can run. The 4 module can is 52 inches tall and the 2 module can is 35 inches tall, and I'm going to take you over here in a second to show you those. It does fit in a standard 16-inch stud, and it also can be surface mounted. And it also is plug and play for all the modules, which I'll demonstrate here in a moment. The low voltage wiring harness is pre-installed, and you have the option now to order the terminal board separately. So if you're getting into a project, you need to just get the can in to reserve your space in that mechanical room, and you still haven't determined exactly all of the different types of loads, you can order it without the terminal boards in there, and then you can order those separately as a secondary order before you're ready to even place the order for the modules. And it also does come with the fitted hinged vented door that we have on it. So we're looking at the enclosure modules next to the new enclosure modules next to the old enclosures. As you can see right from a glance that they are about 10 inches larger from the old 4 module enclosure, and the same here with the 2 module enclosure, about 10 inches. What we've given you is an additional headroom because we got about 50% more loads coming into this enclosure, as well as we gave you the low voltage cage down below, which allows you to make up all those different home runs that are coming in of station bus can be made up down underneath in there. As well as, and we've had this for some time, but we have the plug and play capabilities. Breakers turned off, flip the little tabs, and you can pull those enclosures out, and that's the dimmer modules, the reverse phase dimmer modules and relay modules with the green boards. An additional feature with the new standard dimmer module is we've actually got latches on the sides now that just grab, disconnect those, and very easily to pull that out and reset that back in. And so by doing this, this allows you to be able to land all of the loads on the enclosure boards, and then to be able to put the jumpers into place and to run those just by flipping the breaker, and then you don't have the expensive part of the modules out on the project until all the fixtures have been tested and know that they're working correctly. Another thing to point out here, in the old dimmer module enclosures, you've got the ability to put in the new standard dimmer module as an 8 load module. So even an old Q-Link job, if I've got a module that goes out, I can replace it with the new 12 load. Only have 8 loads capable on it, but I don't have to do any changes to the software or anything like that. Same thing with Infusion jobs. I can go in, use the retrofit boards. I can flip over the black back box and use the wiring harness just the way that it normally was. Come in, and I'm good to go. So there you go. There are 2 new enclosure modules. Let's look at the enclosure wiring. With the standard terminal boards, your breaker feeds, you have 2 per side. So with the 4 breaker feeds, they're marked A, B, C, and D. And as mentioned earlier, if I don't need that much power on a board, I can jumper the breakers between with the line and the neutral from 1A down to B section, or if I need to do the entire module, I can do it that way. Keep in mind that if you're utilizing the arc fault breakers, you do have Even though it's a 20 amp arc fault breaker, you no longer have the full 1920. It is derated down to 1,000 watts for a 20 amp breaker, or 750 watts on the 15 amp.